Good evening, everyone. If everyone would like to find their seats, it's a pleasure to see so many familiar faces as well as so many new faces as well. My name is Andrew Treitz, and I'm a professor in the Institute for the Oceans and Fisheries. It's my great pleasure to welcome you to the 17th Larkin Lecture and the awarding of the second P.A. Larkin Award that recognizes a leading fisheries researcher who is committed to research excellence, inspiring education, and innovative societal engagement. That person, as you all know, is tonight's speaker, Dr. Thomas Quinn. I want to begin by acknowledging that the land on which we are gathered is the traditional, ancestral, and unceded territory of the Musqueam people. I'd also like to thank all of you who have joined us online. We have quite an audience watching from afar throughout British Columbia, as well as those who are here in person, for being with us for this special evening. I first met Peter Larkin in the spring of 1980 while I was an undergraduate student at McGill University. He'd come to give a seminar at McGill. Over the next decade, I got to know Peter Larkin as a remarkable person, a mentor, researcher, and educator. I'm therefore very pleased to have his daughter here with us tonight, Gillian Larkin, to tell you a little bit more about her father and the Larkin Award. Gillian?
Thank you very much. Just out of curiosity, how many of you here today are attending your first Larkin Lecture? Quite a few of you. Okay, fantastic and welcome. This slideshow going on here has hopefully given you some idea of who my father was. He's been gone for more than 25 years now, and many if not most of you never met him. So to introduce these lectures, I'd like to tell a short story that adds to the picture that the slideshow provides. And if you have heard this before, please indulge me. At the 1992 UBC convocation ceremony, my father received an honorary DSc and then gave a short address to the science graduates. He started out by talking about how he and my mom graduated with biology degrees from the University of Saskatchewan on a spring day in 1946, just like those students in the audience in 1992. He talked about how his head was stuffed full of the latest and greatest knowledge, and he figured that he was set for life. Then a few years later, someone discovered DNA. Hadn't had any lectures on that. Then faster computers and new software came along. Hadn't had any courses on those either. He continued with similar instances of new findings in geology and chemistry, and in his mind, all of these examples served to demonstrate that not only were there new things coming along that they hadn't been taught, some of the things that they had learned were just plain wrong. So he wrote to the U of S asking for a refund. Unfortunately, the university didn't agree. They came back saying they couldn't be responsible for post-graduation discoveries or words to that effect. He then went on to tell the audience that UBC, unfortunately, had the same backward policy. He then proceeded to address then-President David Strangway directly, asking for change. He pointed out that the scientific literature was expanding at an astronomical rate. The literature was doubling every 8 years, and in some disciplines like molecular biology, it was doubling every 18 months. This meant that more than 90% of what would be known by the year 2000, only 8 years away, had not yet been discovered. Figures are likely even more overwhelming today. But he had a solution. He suggested that graduating students be sent forth into the world with best before labels that indicated when their education expired. In order to be relabeled, students had to come back for refresher courses. Thus, he argued that graduation diplomas should come with detachable coupons for these refresher courses, redeemable within, say, 100 years of graduation. All kidding aside, he then delivered his key message. He pointed out that many people in society don't go to university, and many of those in university don't take science. As science graduates, that class of students were joining less than 2% of the population of Canada and less than 1% of the population of the world. He maintained that it was the societal responsibility of this elite group to use their powers of analysis to weigh the evidence and speak up when others sought to fool the public, be it for fame, fortune, or political gain. He firmly believed that the most important thing provided by a university education is the thirst for more knowledge to keep you well informed throughout your life. Indeed, my father was more than a great scientist, teacher, or administrator. He was, above all, a great student. This event meant a lot to my father when it was first established and continues to be very special to our family. This award and lecture honors and celebrates my father's excellence in 3 aspects. First, he made outstanding contributions to his field through excellent research and innovative societal engagement. Second, he excelled in this medium. When my father lectured, he was energetic, engaging, and witty, with a contagious enthusiasm for science and learning that infected his audience. And you can probably see a little bit of his goofy silliness in the slideshow here. And third, he was an excellent mentor with demonstrated eagerness to engage with students and early career scholars. These 3 aspects, excellence in research, communication, and mentorship, form the core criteria for the selection of Larkin Award winners. Importantly, we look to you, the audience for these lectures, to suggest nominees for subsequent awards. Nominations for 2026 are now open. I invite you to reflect on who you believe embodies these attributes and encourage them to complete the nomination package. Nominations are due by November 30, and all the information about the nomination process is available on the IOF webpage dedicated to the Larkin Award and Lecture. So on behalf of my sisters, there's 4 of us in the pictures up there, and I'm number 5. I would like to thank all of you for coming in celebration of lifelong learning. This lecture series has to date allowed 16 experts to share with us their passion for fisheries science, and I look forward to Dr. Quinn sharing his insights with us as the 17th Larkin Lecture speaker. Thank you.
And I'd like to call upon Professor Chris Harley to introduce our speaker and PA Larkin awardee.
Well, it is my pleasure to introduce tonight's speaker, Dr. Tom Quinn. I am told that he will self-introduce to some degree, which gets me off the hook for a lot of what I was going to say. But I will mention that he was a postdoc at the University of British Columbia working with Peter Larkin before taking his faculty position at the University of Washington. And I suspect that in your self-introduction you will not brag about your impact. So I will go ahead and do that on your behalf. There's hundreds of publications and tens of thousands of citations, yeah. But I was particularly impressed with the Distinguished Teaching Award and the Distinguished Mentorship Award and the Excellence in Fisheries Education Award, the Jack Williams Award for Applied Conservation Science. A lot of people have had a lot of very nice things to say about you and all that you have accomplished to date. I don't hope to encapsulate all of that, but we are very pleased to have you here. So thank you for coming, and we're looking forward to your presentation.
Thank you all for coming. Thank you tremendously for the honor and privilege of this invitation. And it is wonderful to be back in British Columbia, where I met my wife and had wonderful opportunities to launch all kinds of personal and professional relations. Not to make too fine a point of it, if you like what I said, maybe you'll let me stay. I'll just put that one aside. Okay, here we go. So I was born in the city, as we would say, and there salmon were lox on bagels with cream cheese, and these bears are actually in a diorama at the American Museum of Natural History, although notice that there is a salmon at their feet. This is, I guess, kind of generic Alaska. I was always a natural history kid. My brother and I liked to go to the museums, the zoos, and it never occurred to me at that time that I would have the privilege of working in areas with large populations of bears and salmon and work with the kind of ecosystems where I have. So that's, I've come a long way. As a kid, and I know this is going to sound a little silly, but Rachel Carson's book, The Sea Around Us, and the Scuba Diving with Jacques Cousteau had an extraordinary effect. It allowed people of my age, my generation, to dream about marine biology and oceanography and make it happen. And I was actually kind of a long-haired hippie kid in New York in the Earth Day celebrations, and that seemed kind of fringe at the time, and a lot of those have been incorporated into more common values. And we also knew at that point that blue whales were being hunted to the brink of extinction. I'd never seen one. In fact, I still haven't seen a blue whale. But it made an impression on me that this animal was going to go extinct. And it just didn't seem right, even as a high school kid. And I guess I was feeling existence value. I just wanted to know that they were still out there. And I must say that I'm very pleased that they are. And maybe one of these days I'll get a chance to see one. I went to a small liberal arts college on the East Coast called Swarthmore. There was no fisheries, there was no oceanography. It was just a basic biology degree. I got my PhD studying the idea that salmon could use our planet's magnetic field to orient their movements. I say that to make clear that I was not a conservation biologist. I was, if anything, sort of a sensory physiologist. So a pivotal moment, I read this book by Bruce Brown called Mountain in the Clouds, 1981, still very worth reading. And it was kind of a galvanic effect because he talked about the many things that humans had done to salmon, dams, logging, all sorts of things. And it was kind of what we, in that era, the hippies would have called a consciousness raising experience. So I'm doing all this neat work on sensory physiology, which still excites me, but it wasn't really contributing anything to the conservation perspective. And I met a guy named Jeff Cederholm, and he was one of the first people to work with the logging community to try and improve logging regulations and thinking about the role of salmon carcasses and nutrients. And he was someone who worked for the Department of Natural Resources, and he was someone that made a difference. And I started thinking gradually, maybe reorient my career a little bit. So what am I doing here? I want to transport you back. Those of you who are students can literally think about it. Those of you who are older will have to do it in your mind's eye. If you were a graduate student with me in the 1970s studying salmon and trout, what were the big issues? So I'm going to briefly go over the things that dominated conferences and meetings at that time, and then take you forward and say, well, are those things still pressing? And what were the things that were not on or high on the radar screen that are really pressing now, to express, and I think Dr. Larkin would have appreciated this, how much things do change, and to be prepared for both the surprises and the surprising surprises, including some of the legal and conservation things. I'm giving more from a US perspective, but I'm not unaware of, and I'm trying to include a Canadian one. Things are not actually all that different between the borders. So the first in that day, people kept talking about harvest, habitat, hydroelectric dams, and hatcheries, the four big H's, and apologies to the actual 4-H club. And a lot of people still use that expression. So let's take a quick look. Many people now forget that in the 50s and 60s and early 70s, there was very, very intense fishing by the Japanese in international waters. It was a huge issue. Those interception fisheries were clearly taking North American, Canadian, and US origin, as well as Asian fish. Research moved them over and over and over. And since 92, that open ocean area has been essentially a home free zone. That is a huge change. That whole generation of students just kind of forget that it even happened, but that was a very, very big win. US and Canada, of course, had their own territorial waters, and because of the migrations of salmon along the coast, juveniles generally migrating northwards and adults generally migrating southwards, you know, the Alaskans intercepted the Canadian and lower 48 states fish, and the Canadians intercepted the Columbia River fish, and we deliberately caught too many of their fish, and they deliberately caught too many of ours, and they weren't treaties, and now there are. They're not perfect. They've been renegotiated, but it's a lot better than it was. Fisheries management is really hard, but those are really substantial improvements. I think it's worth tipping the hat, and that was, say, 40 years ago. Logging, you could go to a fisheries conference and virtually all the talks would have been on the effects of logging. Big, big deal. And there's no doubt that there were very severe effects on habitat from harsh logging practices. They were modified a lot, particularly under the William Clinton administration in the United States. Not perfect with respect to fish, but a lot better. And we're also starting to realize that trees do grow back and parking lots tend not to. And my joke, better Weyerhaeuser, the logging company, than Walmart. There are worse things to do to land than log on it. And I'm not saying there haven't been problems, but we are having an evolving view. And most of the important science, not all, but a great deal of the important science is now decades old. It's really a matter of application, not discovering new things. Hydroelectric dams, it was widely recognized in the United States, particularly in the Columbia River Basin, but others as well, that there are very, very serious problems from hydroelectric dams. And they have continued, but there has been an enormous investment of money and science and an improvement in the conditions in those dams. People are also starting to realize that when fish migrate down a river with no dams, survival isn't 100%. And David Welsh and various people in Canada pointed out that the Fraser River mainstem without dams has nowhere near 100% survival. So we're starting to take on a more nuanced view, although there's still probably in the hundreds of millions of dollars spent in research and mitigation for dams in the Columbia Basin alone. So still a big deal, but we're seeing it somewhat differently. And hatcheries, if you look closely, you will see here in this picture, Lauren Donaldson, who was kind of the grand old man of University of Washington Hatchery, his student Ernie Brannon and myself in the picture. We had students and we were sampling fish. And in that period, hatchery research was primarily about making hatcheries more efficient. We would adjust the diet, we would adjust the date of release, the photo period, the temperature, to tweak them to improve the survival of those fish after release into the environment. At some point, as I'll get to, they realized that they were a little bit too much of a good thing. But at that point, much of the research was on physiology, improving the hatchery product, trying to make it as good as possible. Then I'm thinking now to transition to some of the changes. So I love this quote from former UBC professor Hilborn. I argue the hatchery programs that attempt to add fish to existing healthy wild stocks are ill-advised and highly dangerous. I like this photo because this is Jennifer McLean, who was my PhD student. She'd actually been Rick Taylor's student, did research with me on the Forks Creek hatchery steelhead, integrating genetics into the changes in hatchery population. So there's been a huge amount of research on the evolutionary processes of fish under culture, uncovering a series of obvious and much more subtle changes that reduce the survival of hatchery fish. And in addition, the consideration of trying to manage stocks of hatchery produced and wild salmon is very, very, very challenging. So we are recognizing that. In fact, now our fisheries management goes through great contortions to balance the fisheries on naturally produced and hatchery fish. Then there were some things that we really weren't thinking about at all if you were in a conference in fisheries. One of them was aquaculture. Yeah, people were just starting over in Norway to put some salmon in net pens. People said, really? Is that going to work? And it was simply not a big issue. And that has swept up with enormous changes. There have been market changes because, of course, in some sense, salmon are a glut on the market. There are so many farmed salmon being produced in Canada, in Norway, in Scotland, in Chile, in New Zealand, that they affect the market prices. There's a complex public perception. Well, is this real fish? Is it farmed? Does it matter? It tastes good. It's fresh. It's available year round from Safeway or Costco or wherever you get your fish. Obviously, a lot of research here on sea lice. I'm not unaware of these very controversial aspects. State of Washington first banned net pen aquaculture for Atlantic salmon and now all species. So we have done away with it. State of Alaska never allowed it. So it's a very big and controversial issue that was not on the radar screen. Another one that was certainly low on the radar screen was aspects of contaminants. Now, it was known that there were some of the legacy contaminants, PCB, DDT, and so forth, but now there's a huge uptick of research on the ecological effects of some of these contaminants and new things, chemicals of emerging concern, pharmaceuticals, and so forth, on the health of individual fish, on the health of organisms that eat those, including but not limited to humans, harbor seals, killer whales, and so forth. I don't mean that there wasn't any research, but if you look back in the late 70s, it was very, very slim. And now there's a tremendous amount of this research on salmon and, of course, many other fishes as well, including the fairly recent discovery, tire rubber. Yeah, tire rubber. There is a horrid syndrome of what they call rapid onset mortality. Coho salmon come in the first rains of the fall, and they go through what it looks like hideous epileptic seizures, thrash themselves around in the stream, and are stone cold dead. That there are chemicals that have actually been identified in this particular paper, specifically coming off tire rubber. And that was one we definitely didn't see coming. The thing that makes your tires last longer when it does rub off has tremendous negative consequences. And the ocean, we're realizing that the ocean is a way more complicated and changing place. So pyrosomes, I'd never heard of pyrosomes. They look like a translucent cucumber. And apparently off the coast of California, just staggering numbers of these organisms out there. People didn't know about them. Only a handful of people even knew they existed. The ocean threw us a major curveball and likely will again. I met one of the folks here doing this kind of research, and I saw the poster there, but too many anchovies? Really, if someone had told us in the 70s that too many anchovies were going to be a problem, we would have laughed in that person's face. Well, it turns out that they produce thiaminase, which breaks down the thiamine and results not in mortality of the adults, but can strongly affect the survival of the embryos. And it was really a big focus in California. In fact, a lot of people there say that's the premier problem for wild stocks. Of course, in a hatchery, they can treat it, but that doesn't help the wild populations, and it afflicts coho salmon as well. There's a similar syndrome in the Great Lakes and the Baltic, so it is not unique to here, but this was not something that we thought about. In fact, most of us don't think very much about fish nutrition. We just think about, is there enough in their stomachs? But here we're talking about very subtle and important aspects of food quality that, well, certainly I never thought about. Invasives, and you could fill up the slide with as many as you want, but zebra mussels, I'm told, were first reported in North America in the 80s, so at least a decade after I left graduate school. And in certain areas, they're just an enormous problem for physical infrastructure. And God help us, once they get established in the Columbia River around those dams, it's almost certain that they will. New Zealand mud snail. Thank you, New Zealand. They sent us Peter Larkin and mud snails. Sorry, I couldn't resist. In the 80s, whirling disease, a whole host of organisms that come over in ballast water or something like that. Not that we were unaware of those, but if you went to a conference, those would not have been a big deal. People were not talking a lot about them. Predatory fish, I'm not mocking these individuals. The fellow on the left is my revered big brother, and the fellow on the right is his son, my nephew. These are high-end sport fishermen, but a tremendous amount of the fish diversity around here is affected by non-native species, many of which were brought out here for recreational fishing. And to grow big and fast, they not surprisingly eat things. And so largemouth and smallmouth bass and walleye and so forth. So we've really changed the fish community. Not that that hadn't happened back then, but we weren't talking about it a lot. It wasn't prime in the discussions. We were discussing other kinds of things. Not to be smug, even the Alaskans have these problems. Northern pike are native to parts of Alaska, but not to other parts. And it appears that somebody with a float plane put some pike in the float and went to another lake and let them go. But now there are pike in many, many lakes where they're having a huge effect on salmon and trout, although there are other parts of Alaska where they're not ecologically dominant. And Alaska Department of Fish and Game is spending huge amounts of money to suppress, because they'll never eradicate, to suppress northern pike, even though they're native to other places. And they're in the upper parts of the Columbia Basin. They're like one dam away from the zone accessible to anadromous fish, and that's not going to be good. Pike are highly omnivorous, but they love eating fish, and little salmon will go down just fine. Not just non-salmonids, though, but salmonids as well. So someone brought lake trout into Yellowstone Lake. They're not native there, and they had a devastating effect on the native cutthroat trout. Lake Yellowstone is a very large lake with a very, very simple fish community, and it took a massive hit from lake trout. They will never be eradicated. People have figured that they were probably brought in the 80s, back calculating from otoliths, but that was not something we were thinking about. Although, of course, there were many non-native salmonids. So we have so-called eastern brook trout here in the West Coast. We have brown trout brought from Europe to East Coast of North America, and now out here. You can catch rainbow trout at the East Coast. There's been a huge mix and match of salmonid as well as non-salmonid fishes. I think there's a greater appreciation now the ecological effects of some of those things. Although that's a done deal. We're not going to take them out. We're not going to ever take those out. You knew this was coming, Andrew. Marine mammals. So when I came out here as a graduate student in the 70s, if you went out in Puget Sound with a buddy fishing and you saw a seal, you would write to the newspaper, but it was unusual. You would say, whoa, we saw a seal today. It was a very, very unusual thing. And you never saw a sea lion because we just come off the Marine Mammal Protection Act. And the burgeoning populations are something that really came very, very fast, particularly harbor seals. And I know the legal situation in Canada with the Fisheries Act is slightly different, but there's some broad overlap in the timing. And Andrew has written on this and many other people. This is a huge upsweep. Eventually, they've reached a carrying capacity. Things have learned how to eat them. But this is definitely a different thing. The whole predator environment, of course, osprey and eagles have been terribly reduced by DDT, and they came on as well. And seeing an eagle was unusual, or an osprey, and now they're very common. They're marine mammals. They're special. They got big eyes, and they're mammals. So in some cases, we want to suppress them because they're eating our fish. But in other cases, like killer whales, they're sort of more special than the other special animals. We may reduce our fishing, and there's serious talk about increasing hatchery production because they're starving to death and we have to feed them by either cutting back on fishing or releasing more Chinook salmon. So the marine mammal community, I don't mean just the people marine mammal, but the suite of organisms is interplaying with salmon conservation in complicated ways involving our laws, our policies, ecology. Of course, they eat other things besides salmon, and so there's a little bit of a obsession with how many Chinook salmon does a harbor seal eat. In fact, they eat a lot of herring and other things. It can sometimes suck the air out of the room, and that's been a really big change, and not necessarily good, but it is a change. Another change is the whole perspective of dead fish. And again, I used to give credit to Jeff Cedrum. I said, Jeff, you were into carcasses before carcasses were cool. He was one of the first scientists that got out there and he tagged dead fish to see how far they would drift downstream and what animals scavenge them. The fact that salmon die and get eaten is not exactly late breaking news. You smell them. The native people, of course, knew all about this, but it wasn't a big scientific effort. Now, there were papers way back in the 30s on the potential fertilizing effect of sockeye salmon in certain lakes. So it wasn't as though nobody knew about it, but it wasn't a really big deal. Thanks to a number of investigators, in fact, I would credit John Moore here in the audience, we're thinking much more about the ecological role of salmon, not just for charismatic things like predators. This Russian brown bear is kind of eating a salmon like an ice cream cone. That Dolly Varden, we pumped her stomach and she'd eaten over 1,000 sockeye salmon eggs one at a time. So they're drifting down the stream. These are eggs that would have died anyway from UV, and she's picked them out, pick, and work of John, Daniel Schindler students, and many, many others have indicated the tremendous importance of so-called salmon-derived, marine-derived nutrients, because otherwise nutrients are always flushing from the uplands down out to the ocean. It's one of the few ways that nutrients go back up against gravity. They feed bears 50 times the density of bears in coastal areas with salmon than in the interior of Alaska. People have obviously looked at the appearance and arrival and consumption by eagles and all kinds of organisms. Tom Reimschen of UVic studying wolves and other sorts of organisms. You can cut needles and look at stable isotopes and see how the chemistry of the carcasses is incorporated. In fact, the use of stable isotopes played a really big role in this kind of work. It's now very, very common in the kind of public business, and it really wasn't something being talked about that. Another kind of interesting issue as we're sort of drifting towards social science is catch and release fishing. This is actually Andrew Hendry, who was Rick Taylor's postdoc here, is now professor at McGill University. In the early days when people are poor, you catch fish, you'd eat it, unless it was too small or the regulations didn't permit it. But the idea of catching fish with the intent to let it go is actually illegal in some countries. And to other people, to kill a fish like this, if you legally could, would just be an abhorrent thing to do. People have been excoriated on the web for killing a wild steelhead when it was legal to do that. And in other cases, people think it's insensitive or you're just playing with the fish, it's not your toy. And views of indigenous people and non-indigenous people may vary on these things. That was not something people were talking about. And we have a huge scientific literature now on the survival of fish after release. Scott Hinch, Steve Cook, and many people like that have looked into the physiology as well as the sociology of letting fish go. Why do we go fishing? Do you bring it home to eat it? Do you eat everything you catch? The fish can't hide. We have Google Earth, we have GPS, we've got fluorocarbon line, we've got all the advantages. They can't hide. If we want to all go out and catch fish and eat them, we'll just crush them. Even in remote areas of Alaska, lodges are on floodplains. They can't hide. And so we have to decide, are we just not going to fish? Are we going to fish and let some go? Are we going to eat some? In all honesty, I fish and I eat salmon when it's legal and they're in season, and I also let trout go. And so I find myself so in between, but I don't disrespect people who take other perspectives. We also, in those days, tended to think about stocks of salmon, the important stock assessment. And we're starting to realize over the last couple of decades the importance of the numbers of small populations or populations that are now small, starting to think more about biodiversity of salmon rather than just the biomass, managing for more than just tonnage. This is a paper that some of us were involved in that Daniel Schindler was the lead. The idea that all those small populations contribute something either to the people who fish for them or to the ecosystem or the animals. And so we don't want to lose all of those populations that are small, and also populations that are currently small or unproductive may become staggeringly large in subsequent decades. There are many examples, particularly from Bristol Bay, populations that were pooping along, and hypothetically, if you're going to build a dam on one of these rivers, you'd say, we can just write that one off. That'll never do anything. And now there are staggering numbers of salmon there. So we're learning how these things go up and down, out of sync with each other, using the metaphor of stock portfolio that has more diversity, pharmaceuticals and farming and high tech and so forth, gives you a better long-term yield and less whipsaw back and forth than one that has only a single one. And that's been a perception changing in fisheries management as well as science. We need to study more than just the one or two big stocks because the other ones matter. They may become big and they also perform differently. This I show with some trepidation. One of the great privileges of my career was having a chance to go over to Kamchatka, the huge peninsula in Russia, and first meet Russians as people. Because I mentioned to a few of you earlier, when I grew up in New York City, every single day at noon, they sounded an air raid siren. Every day as a warning to test the system, so if there was a nuclear attack, we would go to a shelter. And that was my impression. And to go and see Russians as people, not as enemies, was incredibly powerful. I'm deeply upset by the current situation. I don't want to talk about that, but we did not know much about Russia. We didn't know what fish were over there. We didn't communicate with them. The INPFC was Canada, Japan, and USA. Russia was not involved in that. The data didn't flow. The scientists didn't flow. And that part is better. We know more thanks to the Wild Salmon Center and a number of other people. It is better than it was. It's got a long ways to go, and obviously circumstances now have set it back a lot. But certainly in the 70s, it was just terra incognita, but for a few things translated by Israeli, Russian origin, we didn't know anything. Well, anyway, there's Nikolai Lenin giving you what for, and a Russian bear. The Russians asked me when I saw their bears, are these bears bigger than your bears? And they were just crestfallen when I said, well, they kind of look about the same. Yeah. And I could tell that they were really unhappy. Said, but your salmon are way bigger. And then they were kind of, okay, all right. That and a shot of vodka, and I was back in their good graces. But it was really neat. In the old days, we talked about warm years and cold years, but the idea of climate and trends were not discussed. We didn't have any satellite oceanography. We didn't have synoptic views of these sorts of things. You just were putting a dipstick in a creek. And now we're seeing the increases in temperature tremendous. And of course, we're seeing them all over. You're all familiar with it. People like Dick Beamish at DFO, Nate Mantua, and Bob Francis are starting to put together the links between oceanographic conditions, atmospheric conditions, and salmon populations. And now we talk about that as a, well, yeah, sure, but it wasn't a yeah, sure. It wasn't all that way. People doing really good patient research provided a new perspective. Rather than just having warm and cold years, we would have runs. And it's not all about greenhouse gases. There were also runs driven by climate shifts with important effects on all kinds of organisms and salmon, but far, far more. Part of the problem was, and I don't want to caricature this too much, but I think it's true. In my era, the salmon biologists thought, look, all the limitation for salmon is in fresh water. It's either spawning ground limitation or rearing in streams. The ocean is maybe not technically limiting, but it is limitless with respect to salmon. All the population regulation was believed to occur in fresh water. It didn't change in any important way, and we couldn't know it anyway. So it was this black box into which smolts went in, and well, I mean it. We also didn't talk to the oceanographers. That was another important point. Oh, and shame on us as well as them. Really. And now, of course, we know that all of these things are completely untrue. There are carrying capacity effects that are showing in the growth and survival of salmon in the ocean. It changes in really, really dramatic and powerful and profound ways. And we can know a little bit more about it, although it's still hard to know. So just a couple of examples. Japanese chum salmon, they started reporting as they released more and more chum salmon from their hatcheries in Hokkaido, the northern part of Japan. Salmon that came back were smaller. It's like, what's up with that? And these are just some data from our Bristol Bay program, the males and females of a couple different ages. More salmon, smaller salmon. There really is some carrying capacity out there. It is not infinite. Are they starving? Probably not. They're growing slower. And we've also seen competition between species of salmon, between stocks. And that was hinted at in the 80s, but it wasn't really a very big deal. In addition, we knew that survival at sea changed from year to year, but it was just kind of bouncing around. And now we realize that it really was not bouncing around at all. So this on the left is data from a grad student. These are coho salmon survivals, wild coho in Washington, and they were routinely having 20% survival, and now it's maybe 2% or 1%. So a huge drop in survival. The graph in Alaska is kind of fun because it's not showing survival, it's catch, but of course you can't catch fish that haven't survived. Around 1900, of course, a lot of the fisheries hadn't capitalized, right? There just wasn't a lot of gear, although they still caught a lot of salmon in the 20s with what we would now call pretty primitive gear, recognized in the 50s and 60s to the early 70s. I mean, Alaska was short of salmon. They were building hatcheries for pink and chum salmon because they were short of them. And things took off like a rocket. But it wasn't as though the next year we said, oh yeah, the world's changed. People look back with statistical models and say, right about 1977, things started to change in these climate-ocean interactions, different in the northern part of the range of salmon from the southern. Things in California and Oregon and Washington started to go down. Grandpa said, you always used to catch more fish. He might have been right. And areas of Alaska started seeing higher survival, markedly higher survival rates, higher abundance. So there were really big runs, whether you call them regimes, things like that. And now they're part of our general conversation, but that wasn't what people talked about. It was like a good year, a bad year, a cold year, a warm year. There were also a lot of legal changes. And, there's that old Neil Young song, Look at Mother Nature on the Run in the 1970s. She remembers, someone remembers that. Well, actually, in some ways, the 1970s were a big decade for Mother Nature, at least in the US. So we had in Alaska, Native Claims Settlement Act, because of course, the United States government bought Alaska from the Russians, and then it was a territory. At some point when it became a state, the state said, well, we want some land, and the feds kept a lot of land, and the Native people said, well, yeah, but what about us? We live here. What's our gig? And so they settled that. Marine Mammal Protection Act in 1972, Clean Water Act, and many of these acts have had modifications. 1973, the U.S. Endangered Species Act is a huge, huge act, and it wasn't enacted for grizzly bears or California condors or whales, but it had a huge effect. And that act, the full force of that act applied to distinct population segments of salmon, even though in other parts of their range, they're staggeringly abundant. It's really very, very big deal. It's a very powerful act. United States versus Washington adjudicated and eventually went up to the United States Supreme Court, tribal fishing rights in Washington. And there was a more or less parallel and slightly earlier tribal Oregon decision affirming treaty rights. And there was a lot that followed. Things were really rough for quite a while, but that was a very, very big change. And of course, in 76, a lot of people think, well, of course, we've always had a 200 nautical mile limit. No, we didn't. 76, the U.S. claimed 200 nautical mile exclusive economic zone, and that made us control those waters, and that was a very big deal. Canada, you had your Species at Risk Act, and again, the Species at Risk Act and the ESA are not exactly the same, but what I'm saying is during these last couple of decades, there have been a lot of changes that affect our consideration of endangered or threatened species and the habitats on which they rely, including, but of course not limited to salmon. I confess I found the language of this hard to get through and kind of long, but the essence of it is here: monitoring the status, education and public awareness, starting recovery strategies, habitat, and research projects. That's not a bad mission statement overall. So in addition to these changing research perspectives and laws, there have been kind of changes in management and responsibilities. Early on, it was mostly government-funded projects. You go to the state or the federal government. Canada, you would go to NSERC or DFO or someone like that. Things have diversified hugely. So in Washington, Native Americans have a very, very strong role in funding and in conducting and enabling research and monitoring because they are the legal co-managers of the fisheries. They are not on the outside, they are legal co-managers, and that has been an enormous change. There was, to be frank, blatant racism. At the time I came as a graduate student, there were shots being fired between non-Indian and Indian fishing vessels. Vessels were being rammed. I mean, it was to say it was acrimonious would be an understatement. And it's not perfect, but there's been an enormous change as a cadre of researchers has come on, and those earlier ones have passed into retirement. So the Gordon and Betty Moore, this is more like Intel Inside, that Gordon Moore, philanthropist. So the role of those charitable foundations in research and driving the agenda, World Wildlife Foundation, intertribal fish commissions is a hugely diversified set of funding sources and political entities and priorities. In some ways, you might say that makes it better, but it definitely makes it more complicated. Just to give examples from BC, you just didn't see these things back then. You might not you just take my word for it. You didn't see them. You didn't hear those kinds of considerations. And now they're so prominent everywhere you go in the landscape now, talking about salmon and trout conservation. You see this. So back in the 70s, the focus, like if you went to a Pink and Chum workshop or a coho workshop or something like that, you have a bunch of biologists. First, they'd virtually all be men, which would certainly be different now. But really, each one would be saying, like, how are things going in my stream? We had a really poor run of coho. We had a good run of chum. The floods came early. It was cold, very, very local, trying to understand whether it was the logging or what exactly controlled that stream, because there were no databases, there were no computers, there was no synoptic sense of how many salmon are there coastwide. Just nobody had that information. It wasn't that they were hoarding it, just didn't have it to share. And all of a sudden the pendulum swung, everything is global. So you can't write a scientific paper now without working in global climate change into it. Or if you do, some reviewer will say, yes, but what are the implications of climate change for your findings? And you sort of trot out something. And I don't mean to say that that's not important, because it is, but there's a pendulum that needs to swing both ways. And I love this. There's actually an op-ed in the New York Times, think globally, eat locally. The WAG said, think globally, drink local. But there's a swing back because we're not studying local processes because that's the only thing we can do. We're cognizant of the broader ones, but we also want to have some sense of what we're doing locally. Because most people live someplace and they want that someplace to be better. And the fact that things are in trouble in a global sense can be depressing, frustrating, alienating and off-putting. And people want to have some small sense of control, and I think they should. Simply to say, well, people over in such and such a country are going to burn a lot of coal, and that's going to cook us all. What do you do with that? That's sort of a depressive thing to do. So I love this. John and Sue will know exactly where this is. This is a market up in Dillingham, Alaska, near our research camp, and they gave the kids wooden cutouts of salmon and they stuck them up on the wall there. I love to go to different places and see community involvement and motivation, including both Indigenous people and white folks from New York City like myself, because we live someplace and we want it to be better. And so whether it was the opposition to the Pebble Mine in Bristol Bay, which had a tremendous coordinated resistance by the local native people, the commercial fishing industry, the recreational fishing industry, conservationists, and won the game, removing the dams on the Klamath River, Skagit River, Matsu. These are all good things, basically local people bringing together research and restoration, marshaling funds, pulling out knotweed by themselves to make things better. And of course, this is particularly important for the indigenous people who may have treaty rights to fish in a particular place. So if you're a member of the Stillaguamish tribe, your usual and accustomed area, your treaty rights are on the Stillaguamish River. You can't just pick up and go fish on the Nooksack or the Nisqually or someplace else. And if you're one of the Tulalip tribe, you have an area where you can fish and you just can't go pick up and fish off the coast. It doesn't work that way. And they say, this is our place. And I was talking to one of my former students who works for the Stillaguamish, and the elder came and said, failure is not an option. We cannot fail. This is our river. We have to make it better. We have to have these fish. We're not going to make it without fish, and we're not going to make it anyplace else. This is our place. He was saying this to the conservation biologists, the habitat biologists. You guys have to make it work because this is it. And it's really powerful when somebody says that. But of course, there are non-Indigenous people that also have been on the land for many, many generations and feel that way too. So just a few more of these things, you get the idea. You can find them in BC, in Washington, Alaska, and so forth. I find this really a wonderful thing. The LNC milk salmon, fish, friends of Issaquah salmon hatchery, get it? Citizen science. There wasn't citizen science. In fact, people kind of sneered at the idea that just any old person who wasn't a professional could collect data. But now we're appreciating that there's tremendous value in that kind of thing. Of course, the birding community has been onto this much longer than the fish community, but we're marshaling the power of a lot of people who are motivated to collect information. We also think a lot more about traditional ecological knowledge. There wasn't such a thing, or if there was, it wasn't anything I ever heard about back then. People didn't ask the Indigenous folks what they knew. And if they were asked, it might not have been given the kind of credence that it is now. And that's a change. It's a really marked change. And sort of in general, thinking more about human history. And that's not just self-flagellation, all the bad things that got done back then, but just think about it, learn about it, and think about it. It doesn't mean that what we're doing now has to be different, but we should be aware. And I don't think that we were taught that. At least I wasn't. And I went to it was at the time the premier fisheries school in the US. Tribal scientists, as we have people that are coming into the management scheme, there's a tremendous amount of information sharing that's going on. And I see that as a really good thing. And restoration. And this is something that's kind of interesting because, and I'm a little tentative here, but there was a little bit of snobism, sneering, like social science. Yeah, that's not like real science. We do real science. And that, I think, has really changed. Now, in many cases, you can't submit a proposal without someone saying, yeah, but where's your social scientist? Where's your application? Is anybody going to buy into this? What do the community groups think? And I think that there has been a lot more integration of these, recognizing that the statistics alone won't win you the day if you don't convince people of the validity of what you're doing. And that's a nice thing, I think. And here I am, over 70, straight white guy who's teaching at the university where he got his PhD. I'm the poster child for non-diversity, but I did grow up in the middle of New York City, which was diversity central. And we're not where we might be, but we've certainly made changes. I think at least in the US, the racial diversity is way, 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 way behind. Women have been dominating our undergraduate and graduate program and will quickly come to dominate our faculty, but the racial diversity is we've got a long ways to go there. And I think we're at least owning that fact. In the past, it wasn't even talked about. So I guess that's something. So where does it leave us? We have harvest, habitat, hydro, hatcheries. Those are still issues. They haven't gone away. But I like this line. It was not clear who coined it. I think it was a woman named Shelley Spalding who worked for me. But see, what does salmon need? Rather than what are we doing that's hurting them, what do they need? They want water that's cool, clean, complex in the sense of habitat diversity, and connected. So fix the culverts, remove the dams, allow the streams to meander back and forth, keep it clean and cool, and that's what they like. So what do we do? So one idea is the stronghold approach. Take the best areas and protect them. And there's certainly something to be said for that. But if you think about it, a lot of our laws are not set up that way. They're really more to protect the weakest. So our fisheries management is often constrained by the weakest population. And so we have the Endangered Species Act, Canada's Species at Risk Act, and so forth. So the idea of strongholds may resonate with some people, but that may or may not be what our laws tell us we need to do. And so there's something at least to think about. I'm not a lawyer or a social scientist, but there's some things to think about what we want to do. We can restore habitat. It's time consuming, it costs a lot of money. This is the Nisqually River down near Olympia before the dike was removed. And when I was a student, the idea of removing the dams on the Elwha River was a pipe dream. People would literally think you were high to suggest that. And to see both of those dams go out, not just in my lifetime, but well within my working lifetime, 14 years ago, and 4 very large dams on the Klamath River to go down, that was unthinkable. That is an enormous, enormous change. And here's a photo taken by John McMillan when they let her rip, and a couple of pink salmon. And the Klamath River, 4 really big dams. I mean, there are combinations of reasons, but a lot of this were for environmental, and a lot of the environmental purposes were related to salmon. And there they go. And I have electricity and cars. I mean, I'm not going to live in a cave, but in the U.S., and this paper was published some years ago, over 1,000 dams removed and counting. Many of them obsolete dams in the East Coast that powered some mill for a shoe factory that went under 60 years ago, but also some big ones. And so I know I'm standing between you and the reception, food, beverages. So I'll just say we should celebrate salmon to infinity and beyond. This is, John may remember, this is a Hansen Creek, a 2-kilometer stream, had, after the fishery took half of them in 2014, 60,000 sockeye. Yes, 60,000 sockeye in a 2-kilometer stream, 4 meters wide. They can do it. Just get your heel off their neck and they'll be okay. So I'll take questions. Thank you so much for inviting me. It's been an enormous honor and a privilege. And I'll stick around as long as you want to talk fish. Thanks, folks.
Maybe I can just start off just by, Tom, asking you, like, what's your biggest concern for the future of salmon? What stands out? An easy one.
You to answer that before you give me a beer?
Yeah.
I don't know. That seems more than
Is there one thing in particular that stands out that worries you most or keeps you up at night?
Well, I don't fully understand the ramifications of changing climate in the ocean. And I worry most about things that I don't fully understand. When people talk about not just warmer water, well, I just swim a little bit deeper, but people start talking about circulation changes and think, that I don't really understand. I don't know whether it's alarmist, but it's beyond my ken. I mean, there will certainly be some incremental changes. Things like that worry me because if some, people say, well, those currents going the way they do, there's no law that says they have to. They do that because of temperature fluxes and things that oceanographers understand that I don't. That makes me think, And of course, if some of that were to stall, salmon might be the least of our worries. There might be broad scale issues. There are an awful lot of us people. We may be living lighter on the land per capita with our composting and recycling. It's less harm per capita, but there's a lot of us capitas. When I was earlier on, it was the population bomb, Paul and Ann Ehrlich, and that's just not even talked about. That's beyond the third rail now. Although many countries are slowing their populations down on their own. But the climate stuff that I don't understand in the ocean. Yeah. Hi, John.
That was a spectacular talk. And I guess one of the things I was thinking about is how you've sort of gotten your inspiration. I mean, is it from the Hansen Creeks? Is it from the places? Or is it from like the people? Or is it from the papers you read? I guess I'm just trying to think about like how you feel your thinking has shifted and how it's been influenced by places and people.
Well, when I was a graduate student, I only TA'd 1/4 of one class. I was a postdoc for 4 years. I did no teaching. So I was unbelievably unprepared to be a professor. God knows. I always have been inspired by fish. I was always a fish kid. I kept tropical fish. I learned to scuba dive. So something about the natural world is exciting to me, even whether it's to see a turtle walking around Green Lake. But ultimately, the people that I meet are the ones that carry it forward. I mean, it's nice to go to those special places, but now when I go to them, I really want to bring someone else. The fun now is not to go to that stream again, but to have a postdoc. This year we had a postdoc from Australia, and his idea of carrion feeding was, dingoes and so forth. And he got to see a bear and a moose, and just to bring someone else in that and have them get it, bring undergraduate students. So I came for the fish, but I stayed for the students, kind of. But places do matter, and I remember many of those special places very, very clearly. Yes, sir.
Question there. Well, let's go on back while you're just there with Lisa, and then we'll come down.
Hi, Tom. I'm Jason Long from the Salmon Foundation. When you look at the history lesson you gave us and you look at where we're at today and you have your crystal ball, can you see things that we're thinking today that if you could project, we should start thinking about changing now? Like, what are we doing wrong today in thinking about salmon conservation that we think is right?
Oh, I think you should ask a younger person. No, I'm not being cheeky. That's sort of wasn't it the expression of the problem with life is it has to be lived forward, but can only be understood backward. I wish I'm gonna have to think about it, and I might come up with something, but off the top of my head, that's sort of the challenge. I mean, certainly diseases and chemicals and things like that are going to be changed. There'll be different kinds of ones. I'm not sure.
Thank you very much for your presentation. I really enjoyed it. I'd like to ask you, I don't know how familiar you are with the salmon farming industry out here, but it looks as though by having less salmon farming, we have greatly improved the number of wild salmon around in BC. I don't want to celebrate too quickly, and I'm wondering if you've got a view on what we're doing. You're familiar with it all, and whether you think it's a good way to go.
Salmon farming, you said. Yes?
Yeah.
I am familiar with it. I want to preface it by saying I've not done any research on salmon aquaculture or those aspects. As I said, it was not allowed in Alaska, I think probably in part because the commercial fishermen didn't want the competition. It was allowed in the inland waters of Puget Sound and has now been banned. was very controversial because many of the conservation organizations were very strongly against it. Some of the tribal groups were against it, but others were for it, saying as a matter of tribal sovereignty, they should be allowed to do it if they wanted to. So there were different perspectives. You know, I'm aware of the work done on sea lice and pink salmon. There's a pretty strong body of work implicating sea lice and aquaculture in some of the declines, but a recent paper suggested it may not be quite so simple. In Europe, particularly say in Ireland, the decline of sea trout, sea-run brown trout, has been widely blamed on sea lice, net pen aquaculture. So there's a lot of circumstantial evidence, but because of this recent paper, in fact, I found it and Andrew sent it to me independently, suggesting that things might not be quite so simple. I'd rather hold off and not run my mouth because it's not something I'm expert in. I'd like to see all the evidence. It's a big policy thing. You know, you have some coastal communities that might have income from it, source of nutritious food. Personally, I'll just give you a personal view. I think salmon are a noble animal and they're born to migrate, and sticking them in a pen kind of bothers me just at a purely gut level, to be absolutely honest. And I know that's sort of silly and sentimental, but I'll just leave it at that.
Maybe one last question at the very back. Oh, we have a second question
Oh.
over here.
There's somebody up there.
Scott Hinch.
Hi.
Fantastic presentation. You're a little bit older than me, but I was in high school in the 70s and early 80s, and I remember a lot of what you're saying when I got to university, and it really struck a chord with me.
Thank you.
I've been struck recently with one of the largest changes that we've seen with salmon, and that is the expansion of pink salmon in the Atlantic.
Oh yes,
And-
yes.
You know, that was a surprise to some, maybe not to others. And, you know, now the pinks are migrating across the Atlantic. They've been showing up in Eastern Canada. At some point, they're probably going to go around the north and they'll be connecting with the pinks of the west. Yeah, a remarkable story, a remarkable species. Do you see any other surprises like that coming that you could predict now so we can look forward?
Yeah. Yeah, and at Andrew's suggestion, I've been working on a review paper of this, and I do include that. Those were brought, for folks that are not familiar, Russians brought pink salmon from what they call the Far East to the Kola Peninsula, the White and the Barents Seas. And I think as early as the 50s, they kind of pooped along and didn't really produce very much. In the 80s, there were some review papers, but it wasn't a real big deal. And then about a decade or so ago, they just expanded like a bottle rocket. Norway, Ireland, Scotland, huge numbers of pink salmon. Iceland, successful reproduction in Iceland, caught off Greenland. I mean, to some people in those European countries, the invasion, and that's the way they put it, not colonization, invasion of pink salmon is an enormous threat to Atlantic salmon. And it's sort of perversely fascinating because the Canadians tried to bring pink salmon to Newfoundland, I mean, deliberately, and they made a really big, strong effort, and it just kind of pooped out. So the irony that they might actually come via Russia to the Kola Peninsula from the Faroes to Iceland to Greenland to Newfoundland, that would really be hilarious. Sort of. I mean, you'll certainly know them if you see them. And if you wanted to reduce their ecological effect, you could do it. I guess I'm more worried about things that you couldn't possibly eradicate, you know, whether it's disease organisms or, you know, pike in the Columbia River, that you'd never get them out. It is interesting though. And also Chinook and Coho have been really colonizing rivers down in Chile and Argentinian side of Patagonia, and colonizing fast, real fast. So there are fascinating things there, but that's like a whole separate whole talk. But yes, I'm aware of that. And the Russians have sort of said, well, you should be thanking us. And the Norwegians are saying no. And anyway, you can see where that's going to go diplomatically.
And you have the honor of the last question.
Hi, thank you. That was really incredible talk and what an insight into how science develops over time. I'm really curious, natural history and a love of fish and fishing seems to be part of your story, what brought you to study what you do. I'm really curious whether you see those same factors as what brings today's students to your classroom, and whether you think those are the same motivators or whether it's changed.
I think a smaller fraction of students participate in recreational fishing and hunting. Hunting in particular, not that I've got quite a few friends who hunt, and I don't, I'm not a hunter myself, but I'm not unaware that does say in Washington, the proportion of people buying hunting licenses has gone down. Sport fishing license among the students, I just sort of polled the students in my salmon and trout class, just how many of you, just out of curiosity, have a license? It is only a handful. And I think a lot of them are motivated, a lot of our students are motivated by conservation issues, marine biology. Fisheries per se doesn't resonate with high school students. Marine biology resonates with high school students. And so how much do we rebrand ourselves? I don't have any problem with who I am and what I've been doing, but the demography has, demographics have hugely changed. It used to be when I was a grad student, basically guys who like to fish. Now it's women who don't fish. No, it's not quite, but my class is 80% women. Our graduate program has been 70, 80% women for years. And let me say one last thing, not because the boys let the girls in. I mean, these students are just simply superior students. So it's just a change. It's just a change. And I let it ride because it's not my job to control it. I think our students are wonderful. I'm happy to be on a campus here and see other undergrad and grad students. It's all okay.
Thank you, Tom.
Okay.
I'd like to call upon Professor William Chung, Director of the Institute for the Oceans and Fisheries, to thank our speaker.
So first of all, I would like to thank Professor Quinn for give us a wonderful and remarkable talk. I think all of us would agree that, and I really enjoyed and learned a lot from that. I think it also resonates really well with the opening remarks by Julian about the anecdotes of Professor Larkin's remarks about learning is lifelong. The education that we got from university is just a starting point. I think Professor Quinn's talks really remarkably illustrate that through his career of studying salmon. I think this also provides a lot of motivation and inspiration for our early careers scholars, that I think there are so much things and exciting things for them, waiting for them to study and discover. So with that, I want to thanks again. Thank you so much for giving us this lecture. Thank you. I want to express our thanks with this small gift for you. Thank you so much. Thank you.
And finally, I'd like to call upon our Dean of Science, Mark McLaughlin, to present the P.A. Larkin Award.
Well, thank you so much for having me back. This is the second Larkin lecture I've been to, and I love the lecture. This was a terrific talk, Tom. Thank you so much. And what I really enjoy, too, is getting to know Peter Larkin just a little bit more every time. What an amazing person. And I hope you also could feel him from the kind words that Jillian presented earlier. So I'd like to thank all the people who were involved in organizing this talk, including Andrew and other people from the IOF. And a huge thank you to Jillian and the Larkin family for their generosity to sponsor this lectureship and the award, which I'm about to present. So I'd like to invite Professor Quinn up to receive the award. And it features a beautiful drawing
Oh my God!
from Peter Larkin.
Way classier than my diploma. I love it. I absolutely love it. Thank you so much. And
Thank you.
one last thank to Andrew and the selection committee and all the staff that were so wonderful in dealing with all of the logistics. It's been really, really a treat, again, to come back to Canada, to come back to campus and see you folks. So thanks a ton.